Today we discuss on important topics related to field extension. We start from one theorem now. Okay, just we write the statement of this theorem, then we're going to prove of that. Okay, let f extension k be a field extension. Okay, then every element of f, then field extension which is finite. Okay, which is finite, that means finite field extension. Okay, then what happened, then every element of f, then every element of f is algebraic over k, is algebraic over k. Okay, we prove this one now. So first we write here proof, then going to be that means n be the dimension, let n be the dimension of f extension of k. Let c belongs to f, let c belongs to f such that what, c not equal to 0 and c not equal to 1. Okay, 0 and 1 are algebraic over k. Okay, then what happened, that means if the set 1 c squared c to the power n minus 1 does not contain n plus 1 distinct element, n plus 1 distinct elements. Okay, then here cj minus I equal to 1 for some ij, here 0 less than equal to I less than equal to j less than j less than equal to n. Okay, then that means this one does not contains n plus 1 distinct element. Okay, then this one happen, so c is a root of x to the power j minus I equal to 1. This equation, sorry, difference one, root of this polynomial. Okay, then this one is satisfied. Now that means c is root of this one and 1 c squared, this c to the power n, here c to the power n. Okay, c to the power n, then c to the power n are distinct, all are distinct, then must be this one is linearly independent. Okay, so this one, suppose this one distinct. Okay, suppose this one are distinct, then they are linearly independent, linearly independent. Okay, since they are more in number than dimension of vector space, since they are more in number than the dimension of f over k. Okay, then what happened after that? Here, that means there exists k0, k1 dot kn belongs to k, not all zero, not all zero. Here 0 equal to summation ki c to the power I. Okay, I equal to 0 to n. That means they are of n plus 1 are distinct, and this one are linearly independent. Okay, so that means we see that in the dimension of f equal to n, so this one happen. Okay, that means some linear combination of, or linear combination sum equal to 0. Then that means then this one gives, thus c is a root of some polynomial. Okay, some polynomial summation I equal to 0 to n ki x to the power I over k. So that means how we prove this one easily. That means if extension of k be finite field extension, that means degree is finite. Okay, now we that means we construct this degree or let this degree be n. Then we also, then some c belongs to f, c not equal to 0 1, and then 1 c dot c to the power n does not contains n distinct element. If this one is does not contain n plus 1 distinct element, then what happen? This one equal to 1, c to the power j minus I equal to 1. That means how this one, this c to the power j equal to c to the power I, if that means not contain distinct element, then this one is c to the power j minus I equal to 1. Okay, then c is a root of this polynomial, and then we erase that portion and going to further progression of that, 1 c square dot c to the power n are distinct, then this one are linearly independent. But since they are more in number than the dimension of k, okay, dimension of f over k, then what happened? Then that means we there exists this one. Okay, then there exists this one belongs to k, not all 0. This one obviously, that means some linear combination of c to the power something equal to 0. Okay, thus c is a root of some polynomial, so c is algebraic. Okay, that means if extension of k, then every element of f b is algebraic over k, not a doubt. Okay, c arbitrary, c algebraic over k, and obviously c arbitrary, then every element of f extension of k is algebraic over k. Now we're going to discussion one theorem related to that topics. Okay, we write this theorem again, another theorem also. Let kc extension of k be a field extension. Okay, then Kc extension of K is finite if and only if C is algebraic over K. C is algebraic over K. Okay, that means just correlated to or related to above theorem. Okay, just here if and if replaced by this Kc. Okay, so we use this one, that means Kc be finite. Okay, then this one is algebraic by this that means by above theorem. And now if next part, if C is algebraic, if C is algebraic over K, C is algebraic over K. Okay, then what happened, that means then we also that means from some corollary we know about that this one, this Kc index of K equal to, that means equal to some that means degree of this one equal to some finite number. Okay, that means this one less than plus infinity. Okay, some finite number. That means if extension of K, if C is algebraic, then C is algebraic means C be a root of some polynomial. Okay, and obviously root of some that means polynomial degree is finite, and then this one happen. Okay, not a problem at all. That means this one equal to some P if polynomial C be a root of some polynomial of degree P, then this one be P. Okay, so not a problem at all. So in this way we also that means write this one is finite. That means C is algebraic over K means we write here since C is a root of some polynomial, root of some polynomial, okay, of finite degree. So we write in this way. Okay, this one equal to less than plus infinity, or that means Kc extension of K is finite. So that means we give another example related to this field extension. So we know about that the field extension, this field extension, this Ri, okay, extension of R is of degree 2, is of degree 2. Okay, and 1I is a basis, is a basis of Ri over R. Okay, since this one Px equal to x square plus 1 is minimal polynomial of I, is the minimal polynomial of I, okay, over R. And obviously we know about that Ri equal to here A plus Bi, AB belongs to R. Okay, and obviously this Ri equal to C. Ri is C, the field of complex number. Okay, field of complex number. So today we also discuss this example also. This one obviously example of some field extension. So we discuss one theorem, just one field extension of finite dimension, then every element of this extension is algebraic over K. Okay, so today I stop here. If you get this type of video, please subscribe my channel, and if you that means want to get this type of video and interested on these topics, please see this video regularly and obviously click on like option. So today I stop here.